Oh, so how are how are your arms? How are your tender bits, your fingers? don't
Oh my
don't go
lord.
there.
Well, actually, what's funny is the tips of my fingers do hurt because trying to like contort to get to the wire harness for the sensor, you got to do it all with one hand. There's no way you can get two hands in this small of place. So
Yeah.
you've got to, you know how it's got like the little locking cap on it on the actual sensor itself. It's got
Oh,
kind of like
wait,
a little
wait. Before you get you gotta just like catch everybody up, and so they know what you're
ah,
talking. Before you get into your tiny hand story.
tiny hand story. This is not a tiny hand story, but yeah. So I think on the last episode we talked about a check engine light that came on, and doing a little bit of research, finding out that it was a really cheap part with a really tough place to get. So going and buying the part, easy. Having the part in your hand, easy. Swapping that part out for the old part, challenge.
So we originally talked about potential things we could steal from the automotive industry and tap into architecture, which led to you've got to go work on your car, right? So that's what's
Yes.
happened between this episode and the last episode is you took the job into your own hands and you went in to swap out this bad sensor.
Yeah, so it was apparently it's a part problem that plagues all GMs because there's like 1,001 different videos on YouTube that, to show everything from a professional mechanic all the way down to the shade tree mechanic that has to bleep themselves out at least 100 times during the span of a 10 video.
Yes.
And it's basically the why engineers are not mechanics, or why they hate mechanics or non-company mechanics, however you want to frame it, phrase it, or whatever.
Right.
So its technical term is ambient temperature sensor. But really, it's the sensor that my temperature gauge is flatlined, which means that it's not actually reading. It's not a failed thermostat. It's just this failed sensor that actually tells you and the radiator fans what the temperature of the actual engine is. And when that sensor goes bad and the gauge flatlines, actually telling the engine, hey, I'm overheating, crank on the fans. Well, it doesn't mean that your car's actually overheating, but the fans are going at 100 miles an hour, and usually they only come on if the temperatures in your truck is burning hot.
Yep.
And so it wasn't burning hot. It was just bad sensor. Fans are on all the time. You can burn the fans out. So obviously you want to fix that.
Yeah.
Have a professional fix them, or pull up
Do it
underneath the old
yourself.
shake, or do it yourself. And
Yes.
it was really easy to do yourself if
Was that in air
you're
quotes?
yes,
If you're
if you're
plastic man, is that what you're gonna
man,
say? Yes.
exactly.
Or
Um,
or this is where the tiny hands reference came in. You got to have tiny hands to work on these modern machines.
well, the good thing is that I don't have tiny hands. I actually have pretty large hands, but
Let the record show.
I have
Yeah.
long. Yes, I have. Exactly. We won't go there anyway. So I also am double jointed. So and that is really the only thing that was saving on this particular thing.
Is that in the Haynes manual? It's like double jointed is a requirement to perform this maintenance.
Well, I mean, there's something that's got to be in the Haynes manual to basically inform you. There is almost a complete impossibility that if you don't remove half of the engine bay, obviously, you lift the hood, you're staring at plastic.
Right.
You're not staring at an engine, you're staring at trim
It's
to
like
cover up.
yeah, it's like the modern version of a no trespassing sign, right? It's just
Exactly.
don't go there, man. Take it to a authorized dealer for your mechanical updates. Yeah.
Hmm.
Yeah.
And so you take off all of the plastic, which entails the nice little like shroud that looks like a intake manifold, but it's just a piece of plastic that makes it look fancy. Which is funny because when you take it off,
It's like the Batman chests, like with all the muscles ribbed into it.
yeah, totally.
Yeah, like
Because
the Halloween
when you
costume.
when you take it off, there's a good between that cover and the actual top of the engine where the actual intake manifold is easily a good, I don't know, 14 inches of like just dead space. You're
It's
like,
got wires
why?
and tubes and crap. Yeah, yeah.
You're like, why? Why? I mean, what's the facade?
Yeah.
Which is so funny because they literally like, here's your power plant and here's the facade to cover it over. And it's like when we like, here's your mechanical room and here's the facade to cover it all over, just so you will never see that, it's the Oz of it all.
Yeah. Totally. Behind the
And so
curtain.
so you take it all off, and then of course there's like wiring harnesses you got to loosen up, and then there's a couple of different like pumps and things like that are in the way. And if you take off all of that, happen to be extraordinarily flexible, a la Plastic Man, and are able to like reach down in between a bunch of things, twist your arm around, grab a hold of the top of the sensor wiring, and hope that you can like jimmy your little fingers down in between the wiring harness, like this little release pin, flap, trap, whatever it is that they call the stupid little thing that locks the wiring harness in place. Once you actually like lift that up and pull that off, but because you need quite a bit of like resistance on it, because it's a weather tight cap that goes on there, you have to have a lot of like finger strength to like pop it off. But like most of your strength is like taken up by the contortion.
Yeah.
And
You have no mechanical advantage at all.
None. And there's no leverage or anything like that,
Right.
I mean, because you're now trying to like do I honestly thought that the worst activity working on the headlights was a horrible experience, because you have to go through the wheel well for that, which whatever, doesn't make sense anyway.
Yeah.
I digress. But this, I mean, I watched one video of this guy who had basically taken essentially the front clip, or like the grill, basically the bumper assembly,
Yeah.
completely off,
Right.
so that you can basically stare right at it. Still doesn't make it any easier to like actually like pop the cap off, but at least you actually have a little bit more room to work on it.
And I think you referenced this in the last episode, but I have done exactly this to replace the headlights on the Toyota Sienna minivan that we have.
Exactly. Yeah.
Took the whole front end apart. Yep.
And it's you're like, why headlights, why?
Right.
They're literally, you lift the hood and they're like sitting right there. Remember the good old days when you could just go like my Toyota Avalon, you pop the hood and you can see where the wires go into the back of the headlights. It's quick and easy.
Yeah, no, the bulbs are no problem, but if you want to replace the whole lens because they're like old and yellow, like the van is like 15 years old, right? So they're yellow and scratched, and it's like, now I want to replace the whole thing. I can get them on eBay for cheap. They look great. It like makes your car look new again. And no, you got to take the whole front end apart to do that.
Okay.
It's crazy.
So that's a little bit different than just replacing the bulb.
Yeah.
All I was trying to do is replace the bulb.
Yeah. So yeah, back in the old days, it was all just one thing, right? Like the square 5x7, rectangular.
No,
that was super. That was all one thing. Now it's like this xenon or halogen or LED or whatever. It plugged into the back of a lens, like a crazy lens contraption. Yeah, it's this.
Yeah,
it's great.
And don't even get me started on trying to replace the side marker lights. That's you. I mean, it's death by 1,000 cuts, absolutely, because you have to contort yourself around like the bare edge metal of your wheel well. Yep. And you're just sitting there and trying to like rub back and forth to like get the leverage to like undo it. And then you look down and it literally is just like little slice marks.
Oh yeah. It doesn't matter if it's plastic or metal, it's going to cut you. Like,
yeah. Sure. So the one I think reliable, and we talked about it in the last episode though, the one reliable YouTube video that I had from trying to, figure out how to do this, one mechanic had it down to, and he had some, pretty interesting specialty parts or specialty tools to use. And he had it down to like 30 minutes. And I was like, okay, well, 30 minutes. I think I said in the last episode that I carved out like 2 hours.
Mm-hmm.
And so got all my parts, got everything ready to go, pulled all the tools out, parked the thing, let it cool off. And then it actually, surprisingly enough, I not only replaced the sensor, but I also was adventurous enough because I noticed that I had a headlight out. And when I replace a headlight, I was actually going to the brighter headlight. So I replaced both headlights. So I doubled my misery. Actually, in this particular case, I tripled my misery. And so I did all of that. And surprisingly enough, I did all of that in 1 hour,
That's amazing.
which was, and my wife was just like, I mean, she goes, it's impressive. She goes, because I used to have the old Haynes manuals and I'd flip them open and I'd look at it. And then I look at the tire. Okay, pulled off the tire, pulled off the drum brake. I see all of these springs. That's back in the day when they used to have drum brakes.
Right.
You can see all these springs, and all the springs are crisscrossing over each other, and so there is a very specific way that all of those springs go in. Back in the day when it was prior to like cell phones and cameras and all that other stuff, you just literally have to like make a mental picture of it, or do a hand sketch of it, or whatever of how it went in. So when you take it apart, you basically reverse the action and go back in. This time, I just had keep rewinding just to make sure I like understood where that stupid clip was that was holding the damn wiring harness in. It was so funny. It was like I was struggling with it. It was probably like, no, 10 minutes goes by and I'm like, I can't get the thing undone. So I rewind the video. I watch it again. I'm like, oh.
Yeah.
And then I reach down and I pop the thing, pull it off. Just like that. I'm like,
YouTube is the new Haynes manual. And for all those people, all those youngsters out there who don't know what a Haynes manual is, we'll put a link in the show notes
yes,
because they were a lifesaver. And okay, so why are we talking about this? I kind of, obviously we're doing some follow up from the last one and we wanted to hear about your success or failure. So it sounds like it was a success. But also, like when we're designing buildings, it's interesting, right? Because now all of the Revit families have, like, especially when it comes to mechanical equipment, is what I'm thinking of specifically, is they actually have these clearances built in to the family so that yes, how far away from everything adjacent that thing needs to be. And when you think about automotive design or aerospace or whatever, when it's completely packed into the tightest, most efficient shell possible, a lot of times the answer is like pull the motor, right? So when I had an 87 Porsche 911 and seriously, that was the answer to more things than you cared to ever hear about. It was like, you want to change the timing chain, pull the motor. You want to change the spark plugs, pull the motor. It was like, if you want to do an oil change, pull the motor. No, it wasn't that bad. But it seemed like it.
Pretty damn close.
And it wasn't difficult to pull the motor. Like they designed it so that, you jack the car up the engine, you can just undo a couple of bolts and it comes out the bottom if you have all the equipment to do that. And then you think about these Haynes manuals, which were not designed by the manufacturer. The manufacturer probably hated these things, right? Because they're basically reverse engineering all of the original engineering that went into how to put the car together. And right, like these manuals were a survival manual for the shade tree mechanic. And I loved them too. Like you go to a garage sale and you see one and you have to pick it up because it's got all these beautiful diagrams in it with all these.
It says forward. Anyway,
they're amazing. Like these publications are amazing because they basically told you, like you just kind of like laid out about the drum brake, is like, here's the exact order you need to do this in. Because if you don't, like that spring's going to shoot across the garage, and you're never going to find it again, or you're never going to get put back together right, and you're going to die when you go off the edge of a cliff because your brakes didn't work.
Exactly. Yeah.
And so
this matter of death.
Yeah, these manuals are awesome because somebody, the Haynes Corporation, took it into their own hands to like basically teach everyone how to work on their car, taking all of these things into account. And so then when we design buildings, we don't do this either, right? We're like the car designer where if you're lucky, everything goes together right the first time. But when somebody else in 20 years has to take that HVAC system out and or fix something on it, is there a place to even do that? Like I've worked on a building that it had mechanical rooms, and there was one 2-story room and there was one 3-story room inside the building because the air handling units were so large because it was a science building and there was a lot of air exchange that had to happen. And it's like this machine has to get built inside of a space, and the machine is made out of such large parts. Like what happens when something goes wrong in the future? And you have to think about that and go through that process rather than just like a machine being dropped on a roof by a crane, right? Which can then be popped back off Not easily. You got to have a crane,
Yeah,
but
exactly.
still, like it's not inside the building, kind of buried behind not only walls but other spaces too.
So what's interesting is the current project that I'm working on, it's an existing building, and we're doing an addition to the existing building, and all of the floor to floor heights match the old 1960 building. And I probably said this a couple times. It's 12'8" floor to floor. Modern mechanical systems need a heck of a lot more, especially with lab buildings where you've got a lot of mechanically heavy things going on.
Well, and especially now during COVID, even, and they're talking about air exchange, where
Exactly.
it's always previously been like, what's the smallest system we can spec? Now it's
Right.
not. It's
Exactly.
not like that anymore. Yeah.
Yeah. So we have 15 stories. And so at the very top of that is where all of the mechanical systems are. But because we know that we couldn't get our primary trunk lines down in through chases and stuff because it would eat up valuable footprint, we basically saddlebagged it. And for those of you who do know what it means, is that you're basically putting your mechanical systems along the sides of your building and then feeding in from the outside in. And so that's what we ended up doing. And so that's very, if you think about it, and what's interesting about it is that like the mind of like an automotive engineer, or you and I are maybe not like deep into it gearheads, but we are car guys and we love cars, and that thinking of like how you get your power plant and then your exhaust and all of that other stuff to basically be in the car and exiting out of the car, much like the exhaust system, but without being seen,
Yeah.
is basically the exact same challenge that we have
Mm-hmm.
when we're designing a building, is trying to basically get all of this intake and exhaust and everything else in and out of this building without being seen.
Luckily, ours isn't going 90 miles an hour down the road.
Yeah. So one of the interesting things is you talk about how you'd crane it in there and hope that at least through your lifespan that none of the mechanical system goes down, because then they'll say, "What was Evan thinking? Now we
Right.
can't get this stuff out." Well,
Where's my
we were thinking
clearance?
exactly. So one of the things that we had to do in this particular building is we've got a 9,000-pound elevator so that you could basically disassemble the mechanical system down to its smallest, largest part, be able to figure out a way to like crane it through to that elevator, take it down to the loading dock, and then out the door. But it's just this, we're thinking about, in a lot of cases, we have to always think about the maintenance and the serviceability.
Mm-hmm.
Kind of going back to the analogy of automotive engineers seem to hate the shade tree mechanic because they're not really giving them enough room to actually like operate or repair the car.
Mm-hmm.
We have to take that into account. We always seem to have to think about, and especially in public works, we're a lot of times we're maintenance driven. And so when you're maintenance driven, you actually have to get all of that clearance of like, I think, my most favorite one is like, oh, we can't do 2x2 ACT ceiling tiles because that guy over there,
Can't
he
fit.
can't fit up there. And so
Bubba can't fit. Yep.
they make us think about those things, and
Right.
we do all that stuff. And so thank you to all of the automotive engineers for designing everything down to the nth degree, because you suck.
Box of Band-Aids, man. Box of Band-Aids.
Yeah. They should literally like, so, oh, what,
They're in the
go
glove
into
compartment.
Advanced Auto Parts. Yeah, you just say go into Advanced Auto Parts or whoever else, and you walk in there and you ask for the part. They're like, oh, are you doing this yourself? Like, yes. Oh, well, the first aid kits are over there too. Just go ahead and just get the first aid kit, because I know you're gonna need it.
You're
So
gonna need it. Yeah.
you're gonna need it.